Okay, so how's everybody doing? Good. So that game I was just playing is one of the games submitted last year by students. So by one student, so every student submits a game. And probably for the next few classes, I'll come in 5 minutes early and play something. That's just to give you some idea of the kinds of things that you can end up doing by the time we get to assignment 8 in this course. Because I think for a lot of people, assignment 8 was the most fun, most creative one for them. But of course, making a good game takes more than a week. In particular, planning it out and thinking about it takes some time. And so hopefully by seeing some of these things, you'll get some ideas and get to think about what you would like to make by the time we get there. So how did it go with assignment 4? Do you want to see a solution today? Okay, so we'll go over a solution to assignment 4 today, and then we'll do another sort of similar example that uses some concepts, objects, dictionaries, something useful there. All right, so here's a solution to assignment 4. It's also available on the course webpage. So the first thing you were asked to do is create a track object that has an artist, a title, an album, and I don't remember if you were asked to do a file name or not, but it's not important. And the init method for that track object saves all of those things. That's more or less all it does, is it saves the artist, the title, the album, and I don't remember if there was a file name in the assignment, but it doesn't matter. And the only other method really to implement here is a string method that converts this thing to a string when you, let's say, want to print it. And this string method prints, well, you can see it in the assignment output, track, the name of the artist, and the title of the track. And this is left over from the last year's code. If there was a file name specified, so if there's an MP3 file somewhere on disk, it'll also print that in parentheses after. Okay. So, question about that? First part? I think that was question 1 in the assignment. Question 2 was to create an album type object, or an album class. And again, that has an init method which takes a bunch of things, an artist, the title, the year, which defaults to the empty string, a genre, which defaults to the empty string, and some tracks, a list of tracks which defaults to none, and it saves all those things. Okay, so it saves the artist, the title, the genre, and the tracks. It's supposed to be able to add a track, which remember it has this list of tracks called self.tracks. So it takes an argument that's a track and appends that to it. And it should be able to print itself, convert itself to a string that looks nice. In this case, the string looks like, I don't know where the volume control is for these guys. I don't know. To me, this mic sounds a bit iffy. How does that sound to you guys? Okay. All right. And then a string method that prints the artist for the album, so whose album this is, and the title of the album. And if there's any tracks on the album, it tells you how many tracks. It doesn't print them all out. Or it returns a string of these things. And next up, I think you were supposed to have a load library function, which loads from a file, or is that the last question? Okay. So load library, let's do that one, is supposed to load a list of tracks from a CSV file. The CSV file is provided. And in addition to loading them, it converts them to track objects and then figures out what their relationship is to certain albums. So every track has an album title associated with it, and so it tries to group them by album title. And it's supposed to return a list of tracks and a list of albums. So that's what we create here. And you don't have to do this, but it is a little bit helpful. This code does it. I've created a dictionary which will take album titles and map them onto the albums themselves. So the album titles are strings, and the albums are album objects. So that's what this dictionary will store. It'll be strings mapped onto albums. So we open the CSV file, we read it, we split it into lines, and then for each line, we split that line on vertical bars. And each line is very carefully formatted. Once we split this way, we get the artist, the title, the album, the genre, and the year. So now there's a little bit of logic. We look at the album title, and we see if it's in the dictionary or not. So if we've never seen an album with this title before, then it's time to create an album with this title. So that's what we do. We create an album. This artist, this is the title of the album, the year, the genre, and an empty list of tracks. We append that to our list of albums that we're going to return. And in our dictionary, for this album title, we map it onto this album object. Okay. And then the rest is create the track with the information we have, add that track to the album, which we now know exists. If it wasn't there, we created it. Yeah? It's not necessary. It's just a handy way to keep track of which album titles we've seen and where the corresponding album is. Okay, so right. So the way the way you group things into albums is by looking at the title of the album. So each track has this album title associated with it, and if two tracks have the same album title, then you assume that they're from the same album. And so this dictionary is just a way of keeping track of all of the album titles we've seen before, and for each one it maps it onto the actual album that we've created. So is that clear? No? So how many people are following this? Okay. And how many of you did the assignment correctly as well? Okay, so So what I'm learning is that this is a useless recap because the people who are following this are exactly those who did the assignment correctly. So if you're not following this, please ask me something more. So yeah.
How would you go about doing the loading without using a dictionary?
Okay, so let's do the loading without using a dictionary. So we won't create this dictionary. So the only place we really use this, well, we use it in a few places, but we can get rid of it. And let's save this as version 2, let's say. Okay, so we don't want to use a dictionary. Let's kill that. Now, we still have a list of tracks and a list of albums. So once we see a new track, we can still ask if there's an album with the corresponding title, right? So how would we do that? If we've been making a list of tracks and a list of albums all along, how would we check to see if there's an album with the corresponding title? Well, presumably if we don't want to use a dictionary, we also don't want to use a set.
Using a list?
Yeah, so we've already got a list of albums. So we just look in that list for an album with the title that we're interested in, right? Okay, so what's an easy way to do that? Yeah. Yep, so we could do, let's just turn it into a separate function, so it'll take the list of albums and the album title and do something like for A in albums, if A.title, and we will try and make everything lowercase so it's case insensitive. So if this album's title is equal to the album title we're looking for, then we return A. And if we go through all the albums and we don't find any album with this title, then we'll return none. Yeah? Sure, that's a good idea. Okay. So we've been keeping track of all these albums. When we see a new track, we look for that title in the list of albums we've been making, and either we find it, in which case we return the album object, or we'll return none otherwise. Okay. So now, instead of asking if album.lower is in D, we say if lookup or something, let's say A is equal to lookup album. We look it up in the list of albums. Album. And if A is equal to none, then we've never seen it before. So we create a new album. We append it to the list of albums. There's no dictionary anymore, so we don't need to update that. And A now is definitely the album we want, so we say we add the newly created track to A. So let's try that. Tracks. No file tracks.csv. better get that. So I don't have, oh, I do. I should have saved the data file before I got to class. No, not going to work right now. Okay, so we can't test it because I don't have the CSV file with me. And I also don't seem to have an internet connection here right now. But that should work. I mean, unless there's a syntax error or something in there, that should be fine. Yep. Yep. Well, let's see. So albums have an artist, a title, a genre, and tracks. So A is an album, so we can ask for its artist, its title, its genre, or its tracks. In this case, we're looking for an album with that title. Right. Other questions? So basically the only difference between using a dictionary and not using a dictionary is if you don't use a dictionary, you end up having to write a bit of code which does exactly the same job that a dictionary does, looking through the list of albums for one that has a specific title. And of course it doesn't do it as quickly as dictionaries do. This looks through the whole list of albums, but that's not such a big deal. There's only a few hundred albums here. It doesn't take that long. So questions about load library? Yep. A tuple instead of a dictionary? No, a tuple is usually only one sequence of things. So a dictionary is a whole bunch of pairs. So they're not interchangeable. Okay. And then the actual music library is basically just something that takes a raw input. So that should start with an S, SA, a T, or an S. It uses the string function called partition to split it at the first space, and that splits it into three parts. The thing we're searching for, so that would be this S, this SA, this ST, or this capital S. Some junk, which is the space, and then the thing we're going to search for, the query. We convert the query to lowercase so that everything is always lowercase. We don't have any problems with matching case. And then depending on which command was specified, for example, if it's little s, we look through the album titles, looking for albums that have that title. If it's SA, we make a set of artists. Based on the ones that match that artist's name. If it's an ST, we make a list of tracks for those that match the title. And if it's a capital S, we do a combination of those things where we look everywhere for the text that you're looking for. In any of those cases, the result gets stored in a variable called results, and then we loop through this list of results and print it out. So any questions there? Yeah. Command junk query? Yeah. So I wish I had internet right now. If you look in the string in the string library, there's a function called partition, which is like string.split, but it only splits it once. And so what partition does is it returns three things. Well, it takes one argument, which is where it should split it. In this case, it should split it on a space. And it returns the stuff before the space. That's command. It returns the space itself. That's the junk. And then it returns the stuff that comes after the space. That's the query. So if I type something like, S black, then the command is S, junk is the space, and the query is black. Yeah. String split will do the same thing. If you look at the documentation for string split, what you will find is that it has an optional argument which tells you how many places, the maximum number of splits that should occur. So you can say 1, in which case it'll split at the first white space, and it'll split it only once, so you'll get the first part will be the query, the command, and the rest will be the query. So you can do it that way as well. So for those who got stuck on this assignment, you can tell me now, or you can tell me on the forums. Where's the sticking point? Where do you get stuck? So in previous years, I always thought it was something else. Yep.
I think it's just the fact that we're working with something new, like classes, combined with the fact that we're using a program compared to all the other settings.
Okay. Okay, so you think this is maybe a bit too complex of an assignment to be working with classes for the first time?
Yeah.
Okay. Yeah. Aha. Yes. All variable names are in Python. I see. Okay, I should be more explicit about all of that, actually, variable names being case sensitive. Yeah.
Once I figured out the instructions were fine, but the first time reading through the instructions, I was wondering what exactly
Yeah.
I was doing the right thing, or if there were other things that I could do. I wasn't entirely sure.
Yeah, I maybe should have started that assignment by actually posting the testing output rather than the questions of the assignment. Because I think it's probably easier to understand what it's doing by looking at what a sample run of this thing.
So are you going to submit it?
What's that?
Are you going to submit?
No, because some people work very hard and they'll get the full marks and bonus marks. There will be other hard assignments as well. Okay. All right. We'll see how the marks pan out. Okay, so any more questions about that or comments? Yeah. Mm-hmm. So I think I've said this a few times. It's the last day before the break, so October 23rd. And so that's the Thursday, and then the Tuesday will be a review exam prep lecture. Yep. Sorry, I can't hear anything down here. There's too much squeaking. In the midterm? I think, is it visible on the course webpage? There's a midterm from 2 years ago? Yeah. So, be questions like that. Very similar. Yeah.
Would it just be during like our lecture?
Yes, you'll just come here, everybody will cram in, you'll be sitting side by side, banging each other's elbows. It's going to be awful. The good news, and trying to work with a question sheet and a Scantron sheet. So bring as little as you can. If you have a bag and stuff, just come drop it off at the front. Yeah, so the good news is you have an hour and 20 minutes, and most of the time a good chunk of the people are finished after 25 to 30 minutes. Like most of the class is done after 30 minutes. That doesn't mean that they've all done well. That people, 80% of the midterms get handed in quickly, but historically the average mark on the midterm is about 60 to 65%. Although there should be no surprises because it's the sample midterm is a very good template for what the real midterm looks like. Yeah. No, you won't have to use NumPy. Yeah. Oh, sorry. I was looking at you and someone else was talking. Yes. The midterm is all multiple choice, Scantron. Yes. Sorry, someone squeaked just as you spoke. I think they're circled on the question sheet. I'm not positive though. Okay, so if not, then this is also a useful thing because just seeing the answers isn't great. On almost all of them, they're sort of the form, what would Python do if you type this in? So here's a way to find that out is fire up Python and type that in. You're less likely to forget what it does in that case. Most of the questions are of that form, so it's about reading and understanding code. You could also just run the code and get the answer that way. But we can, we can go over it in class. Okay. All right. So today I want to maybe try and drive this home, maybe do an application a bit like the music library that uses objects, reads from files. Maybe there's a dictionary in there, maybe not. And hopefully something we can have a little fun with, and something that's at a pretty good scale. So I've got a list here of all the world's cities and their populations. How long do you think that list is? Give me a ballpark number. 3,173,958. Okay. It's a CSV file. We'll look at the first little bit of it. Looks like that. There is a country code. There's the name of the city. There's the name of the city written again in sometimes with special characters and capitalized correctly. There's what's called a region code, which would be like a province or a state, depends what kind of country it's in. Latitude and longitude, and if it's available, there's also a population. Okay. I think that's the format. Yeah. So the last two are latitude and longitude, region code, and then sometimes there's a population. I think for most of Andorra it's empty, but if I do, for example, grep Ottawa, so there's lots of Ottawas, but Ottawa in Canada, yeah, there's the population right there. At least according to this file, 874,000. So that's probably before amalgamation took place. So that's the format. And, well, 3.1 million is a lot of things. Not so easy to remember. It would be nice to be able to put this into an application where we can browse it. We can search for cities based on their name, maybe based on a part of their name, so a substring search. So that kind of thing. So if we're going to do that, then, well, there's our data. And I've also got another file here. Which is country codes text file. that has the names of most of the countries in the world, as of, I don't know, whenever I picked up this file, as well as their country codes. And that'll be useful to us because the cities file uses country codes. Might be nice to actually display the names of the countries rather than just the two-letter country codes. Okay? So this is our goal, to make an application which allows us to search for cities by name using this data and maybe by substring and so on. So we want to do this the usual way of starting with a program that at least works, does something. And so where should we start? So this is, someone tells you, make this city, world city browser for me. Where do you start?
Make a class for it.
Make what?
Class for it.
Sure. So think about objects, if we're going to use objects and classes. So what's the sort of class of objects that really jumps out in this application? Yeah. City seems like one, right? I mean, city. It's a whole application built around cities. So we can define a class called city. Might as well start there. City is just some kind of object, and nice thing about that is once you start doing that, as soon as you say I'm going to define a class called city, you've already got a bunch of typing to do, so that keeps you busy while you think about what you're going to do after that. So it's going to need an init method, so when it gets created. And what kinds of properties do these cities have? Yeah. So they have a name. What else? So more generally, a province is called a region. So could, like in the United States, it's a state, and more generally, it's a region. So city can have a region. What else? Country. Anything else? A location. And so location, maybe it has a latitude and a longitude. Anything else? Population. And these init methods, they're often boring to write, but at least it's a lot of typing, something to do while you think about what you're going to do next. Or while you think about what I'm going to do next, I'll type this in. That look good? Okay. What's something we usually want to add to most of the classes that we make if they represent real data in our application? Yeah. A string method. Something so we can print these things and get some meaningful representation rather than just something that says this is a city object at some weird memory location. So we'll want a string method. So let's convert a city to a string. So maybe something simple like so let's say like Ottawa, Canada. So the city name, the country name. And maybe if we have some population, we could say something like well, let's leave it at let's leave that out for now. That's some functionality we can add later. All right, so let's see if we've got something that works. Okay, Ottawa, Ontario, Canada, I don't know, X, Y, and population was about 1 million. There. So, seems we have code that works. We can make a city, and we can turn it into a string, and we get something that gives a meaningful representation. Yep.
When you're making a concrete, like,
Yep.
implication, can we actually make those, convert them to strings in the constructors?
Convert what to string? Yes, you could convert those to strings. If you wanted, you could put string name, although I don't know what else you would use there. But and that is something you sometimes do, like the latitude and longitude. You might want to, instead of converting those to strings, you might actually convert them to floats or something like that. But then you're opening yourself up to a crash if somebody provides you something that's not that doesn't turn into a number properly. And this data file has some issues, so we'll leave that for polishing later. Okay. All right. So that seems to work. Now what should we do? We have our main object. Yeah.
You can create a country class.
Could create a country class. It's not clear yet whether I'll want one of those. So that would be to, for example, group all the cities by country. Yeah. Let's not do that for now because I'm not sure that we'll ever want such a thing. Because you may, I don't know, we're not thinking of supporting, at least not yet, queries of the form, tell me all the cities in Canada. They generally tend to dump out, well, hundreds of city names, so it's not super useful. But it is something we could add.
Could you load the data and format it so you can put in your...
Yeah, let's try and load the data. Okay, so let's write a function called load data. And this is a good one. We have to be a little careful here. So the data file is 145 megs. So let's say data equals read, open, and pop. Okay. So we read the data, we split it up into lines, and we've seen, and what I'm going to do is make a shorter version of this file just for testing. Maybe just the first 1,000 or 2,000. So I made a shorter version just for some just for testing purposes. Okay, so we split it into lines, and then we say, let's call this thing lines for line in lines. equals, or you can do it the fancy way. Country, name 1, name 2, region, population, latitude, longitude. That is equal to line.split. And we split on columns. Okay. So we split the line, and if I got it right, looking at this line, it's the country, the name of the city again, the region, the population goes between these two little commas, and then the latitude and longitude. Now, of course, we're making a list of cities, so we start with an empty list, and then to that list, we append this new city that has, I think we can use name 2 as the name, the region, the country, the latitude, and the longitude. And then we want to return that list of cities. So let's try that. I missed an argument. Population at the end. Okay. Population is there. Yeah, the problem is the confusion is the ordering inside the file is different from the ordering in this constructor here. So, okay, good. So, 2,000 cities in the short file that I made. If we look at city 0, print it. It's that funny looking city with the unprintable character. City 1, city 2, city 3, city 4, and so on. See any issues yet? So we have, well,
You have a country code instead of country name.
have a country code instead of a country name. So we'd like to clean that up. Do we want to do that now or save that as an advanced feature? You can do it now or later. It's up to you guys. Do it now. Okay. So we have this file that has country codes in it associated with the cities. And then we have this other file, which is the country codes file, which has full names of countries as well as actually 3 different kinds of country codes for them. So what is the right tool of the things we've seen in this course? What's the right tool to use to figure out for these kinds of country codes, or the country codes that appear in this file, to figure out what their full names are? What's the right tool? Yeah? A dictionary, right? Because we have a country code, we want to know what the associated country is. That's exactly the mapping that dictionaries do. They take a unique key, in this case it's a 2-letter country code, and they map it onto whatever you want. In this case it's the full name of the country. So before we load up our cities, maybe we'll build this dictionary. And for that, we just do the similar thing. But we open countrycodes.txt. For each line in that, what have we got? We've got the name, and so it's separate. It's a CSV file, but the semicolon is the delimiter. And we've got the name of the country, and then the first thing we care about, So we say name, code 1, code 2, code 3 is equal to line.split, and we split on semicolons. And we're going to use a dictionary. We'll call it code to country, and we'll say code to country at code 1. That's the one we're interested in. It's the 2-digit code is equal to name. Okay. So now we've created this thing that that maps the names, the codes, onto the names of the countries. And where do we use that? When should we use that?
You're making a new city object?
Yeah, when I load the city from the cities file, it comes along with this country code. At that point, I can turn it into the actual name of the country. So I do something like country is equal to code to, so rather than call this thing country, I'll call it CC for country code. Code to country at CC. Is that going to work? Let's try it. Got a little bit too fancy there. Didn't unpack properly. It says too many values to unpack. 1, 2, 3, 4. And I tried to do 1, 2, 3, 4. So some of the lines in here must be not complete. So let's instead just say unpack that into an array and say name equals A at 0. Code 1 equals A at 1. Try it again. That seemed to work. And now we actually get some real stuff here. So the country codes that used to be there now have been replaced with their correct country names. Do you see any possible points of failure here? There's one that I see, and it's that this country code map may be incomplete. So there may be some country codes that are not in there, in which case this thing will throw an exception. And I'd like to prevent that from happening later on, so I will only do this if CC is in code to country.
Now country isn't defined if it's not in there.
Else, else country is just CC. Or maybe even more simply, so if we find this thing in our country code database, then we translate it using that dictionary. Otherwise, we just leave it as is. So there may be, this will fail at least gracefully. We'll get these 2-letter country codes instead of country names, but at least it won't crash this way. So, okay. Where to now?
What else is it supposed to do?
Well, now we want to, I mean, it's supposed to be able to search for cities by name.
So let's do that.
Okay, so let's search for cities by name. Let's start building the actual application. So let's say, I don't know, let's call it run it. So we'll get our list of cities. We've got it. And now we want to, so now what do we want to do? We've loaded our list of cities. What does an application look like? What did the music application look like? What did it do at this point? What's that?
Prompts?
Yeah, so you prompt the user. I don't know, something like enter query. And we can try and do a similar thing like we did with the, like we did before. So queries maybe can be, I don't know, C or C, or capital C, little c or capital C. And maybe one of them will search for exactly a specific name of a city, and the other one will search for any substring in this thing. Okay. So what do we do with our command once somebody has entered it? Yeah, so we want to parse it. We want to figure out what kind of command they're asking for us to do, what kind of search, whether it's a little c or a big C, and then what it is that they're searching for. So I showed you in the sample solution does it one way. I'll do it the other way now and say, let's say A is equal to command dot split. We'll split on a space. I only want to split once. And that means I should get 2 items, which would be A at 0, and query is A at 1. And we might as well, at this point, turn it into lowercase. Yep. I'm missing a bracket at the end of raw input. Good point. Okay. And let's just check this out. That would be, see if that part of the program works. So I'm about to do a C, little c, that's the thing that it's going to execute on, this is the query string. So that seems to be parsing this command into its 2 parts correctly. And do it again. And of course it'll parse all kinds of things that don't make sense, so we'll have to make sure that we don't accept any bad input. So we'll have to sanitize that, but at least we did the parsing correctly. Okay. So for now, there's 2 kinds of queries that we accept, so 2 kinds of commands we accept. If command is equal to C, we'll do one thing. Else if command is equal to capital C, we'll do another thing. And otherwise, print invalid command. Percentage Okay, so here, maybe this will be exact search. Search for cities having this exact name. And this will be substring search, search for cities containing query. All right. So how do we do an exact search? So we have this giant list of cities, 3.1 million of them. How do we find the ones that have a query as their name, have this particular value as their name? What's the tool that we've seen from this course for doing those kinds of things? Sets? Why sets? What? Well, the thing is, I want to know, when I search for Ottawa, I want to know all of the cities called Ottawa in the world, not just one particular one, not just the most populous. So set doesn't sound like the right thing to use. But don't think about that too much. Just, if in the first 2 weeks of this course you were given this question, how would you do it? You just said, you have a list. So you have a list with all the cities in the world, and you want a list that has only the cities named Ottawa. So what's the technique for that? Yeah?
Run a for loop that searches for if the dictionary at this value, at this input is Ottawa, and then the list.
Yeah, so a for loop that goes through the elements of a list and checks each one. If it satisfies this condition that its name is Ottawa, then we add it to another list and output that other list. So is there a more compact way of doing that?
List composition?
List comprehension. So list comprehension does exactly that, right? We can do list comprehensions with this if clause. So what I want is, the result is each city for C in cities, but only if the city's name is equal to the query. Is that going to work? Anything we're forgetting to do? Well, let's take a quick look. Head. Okay, so there is a city called Andorra. So let's try that, searching for that. So, does that work? We didn't print anything, so we should actually print it. But do you see a problem that might crop up? Oops. Comes up all the time, something we always forget to do. Case sensitivity. Good. So the query we converted to lowercase, but the city names, they're all stored in whatever case, capitalized the correct way. And so we should only compare that to the lowercase version. Okay. All right, so that's how we do an exact search. And what about the approximate search? Or not the approximate search, but the substring search. Yeah, it's almost exactly the same, except we only want to know if the substring query is in the name, not if it's equal to the name. Okay. And now we'll do something like for C in result, print C. Good. So there's a city called Andorra in the country called Andorra. Perfect. And any other city you'd like to try? Or any other feature you would like to add to this thing?
How about the whole list of cities?
The whole list of cities. Well, that we can get, I think, just by doing, maybe not. Oh yeah, that should do it. Let's try it. There's the whole list of cities. Okay, so that's another feature we have to add. Is there something else we should maybe add to the program first? So one thing that's annoying is you have to keep running it over and over. And in general, that's not the way you run these kinds of programs, because now we're just running on a sample. But if we run on the entire list of cities, we have to load in 3.1 million cities, and then we do one query and the program exits. So maybe we should put this thing inside a while loop. So for now, let's just do it forever. And while we're at it, let's go for the full list of 3.1 million cities, not just 2,000. So I should keep an eye on this, because we're getting pretty big now. So let's go Python, and let's make this thing run itself. I don't want to have to type run it all the time. So let's keep an eye on the memory usage while we do this. Okay, we made it. Didn't run out of memory, but got close. 6 out of 8 gigs, and many laptops would have. There's the loading phase happening right there. All right. Give me the name of a city to search for. See if this thing works. Kick the tires on it. Ottawa.
Ontario.
You want to search for Ontario?
Yeah.
Is there a city called Ontario?
There is.
Yes, there's many of them. Is there a city called Canada? $3.1 million of these things, right? So there's going to be a lot of them. So maybe we could tidy this up a little bit. And you know, the United States is particularly bad at picking unique place names. So every city appears in every state somehow. So maybe it's useful if we actually print this region when we print the cities. So we'll go back and revisit that and say, so we would say something like Ottawa, Ontario, Canada. So Ottawa, Ontario, Canada. good question. What's PyPy and why did I run PyPy? PyPy is another version of Python. We've been using CPython. CPython is great. It's compatible with the largest number of things. PyPy, however, is more efficient. It's more efficient both in terms of speed, it's more efficient when you use objects, and it's more efficient in terms of memory. And if you look, you can see the memory difference there. This was using CPython. This is now using PyPy here. So it uses considerably less memory. And so I'm just doing it now just to make this quicker, to reduce the load time. So let's see where all these places called Canada are. So you see some of these region codes are kind of useless. They're just numerical codes inside of different countries. But at least in the United States, they are understandable if you know the names of the states. Kentucky, Kansas, I guess. GU, what's that? All right. So, anything else we want to add to this right now? Maybe print the population. Okay, so it's a good chance to show you something. So we print the name of the city, the name of the region, or the region and the country. So Python accepts a lot of things as conditions to if statements. In fact, almost anything. So, there's the usual things. You can do comparisons, and you can use those as conditions to if statements. But you can also put in things like integers as conditions, and you can even put in strings. So here we have an if statement whose condition is just self.population. And because we read all this from a file and we never converted it to anything else, self.population is a string. And it turns out that strings are always true except when they're empty. So if a string is the empty string, meaning it's a length 0 string, then it's considered to be false. Otherwise, it's considered to be true. And so then we could do something like tack on the population. Something like that. See what that gives us. Search for Canada again. So we find Canada and a bunch of these things. Let's try New York. And indeed, we get population numbers for the place that has them. New York, it has a population recorded there of around 8 million. Okay. Any other place names? Any other city names? Toronto? Toronto? Toronto is all over the place. Australia, Canada, Colombia, Cuba, Tanzania, and of course a whole bunch of places in the United States. Yep.
What if I make like a spelling mistake? How would I
You want all of the possible misspellings?
No, all the possible right spellings of my misspelling.
Well, that's a question on assignment 6, so I'm not going to answer it right now. But, to answer your question, you would write a subroutine which takes two strings and decides if one is a misspelling of the other. And so it returns true or false depending on whether they're close enough to be considered a misspelling of the other. And then you would just do, maybe a third kind of fuzzy search here in which in this if thing, you call your function to check if they're close enough to match. So nothing too sophisticated there, except deciding what it means for two strings to be close enough that they might be a misspelling, or deciding what it means to be close enough, and how to implement that. Okay. Well, it turns out that there's a lot of unusual city names, and many of them are depressing. So, hole, dump, yeah, and of course, the United States, even embarrass appears 3 times. Of course, you guys know Springfield. It's the whole joke about The Simpsons is that you don't know where Springfield is located in the US because there's one in every state almost. Here's a place that's not much fun to be from. Another place that's not so much fun. Some of them are not very pretty. Some of them are hard to find on a map. And then there's always Dupressa in Italy. This is kind of a stinky place to be from, but it's not as bad as that. So, speaking of the Netherlands, where is the place in the Netherlands that's famous for partying? Amsterdam. So everybody thinks Amsterdam is the place to go to party in the Netherlands. Actually, this is the real place to go to party. So they do a lot of that in that particular place in Amsterdam. There's other places that seem to have been named, as far as I can tell, after the pastimes that are popular there. So of course there's Toadsuck, Arizona or Arkansas. And there is also Paint Lick, which is a fun thing to do on a Saturday night. Some places are named after their after foods. So beef. You've got chicken. You've got popcorn. Some places are named after drinks, whiskey. And other places, they like to drink vodka. And still others. There's the Beer Bottle Crossing. In Beer Bottle Crossing, there's lots of bad habits there. Some people around there like to roll their cigarettes using Zigzag brand papers. Sometimes they go to Love Hill. They're always careful to use protection when they play Truth or Consequences. So I invite you to explore this World Cities file. I'm sure there's tons of hidden gems in there that I haven't found. And there's a bunch that I did find and I'm not going to show you today. Look for yourself. But for now, that's probably a good place to leave it for today.